Bismillahirrahmanirrahim. I am Professor Jamil and you are watching YouTube channel. Today we are going to start a topic known as integral transform. Integral transform. What does it mean when we say integral transform? Here is the basic idea. You have some function f which depends on the variable x, and you wish or you are required to change this function f into a new function which is capital F, and this new function capital F depends on a new variable t, right? Since you need a change of a function from old function to a new function, you need an operator, and in this case operator is a definite integral operator, and because of this definite integral operator, this change of one function into another function is known as integral transform. Basically the function which you get, this function, new function, this is known as transform, integral transform. Integral transform. So integral transform is basically the new function which you get from old function. And how you get? You get new function from the old function by operating an operator which is a definite integral operator on your old function fx. Now we need to find what this definite integral operator is, and for this case we may start from the definite integral of your old function fx from x equal to a to x equal to b, and each one of you knows that this is an integration over x, and this is equal to this Riemann's sum I from 1 to n. This is the definition of definite integral, right? And we may also write this definition in as longhand, mean expand this sum r a to b fx dx is equal to, use value of I as equal to 1 first, it is fx1 delta x1 plus, then I is 2, mean fx2 delta x2 plus dot 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 plus the last value n, fxn into delta xn, where n is understood to be approaching to infinity. Now what is this? You know, this is area of the rectangle whose width is delta x1 and height or length is fx1. You can plot this. This is your elementary calculus problem. This is x-axis and this is y-axis, which is fx, and to plot or graph of this function is, for example, this kind of thing, and you are integrating. This is value of the function at point x equal to a, and this is value of the function at x equal to b, and here is, this is the point xi, and at this point value of the function is this one, which is fxi, and the next point is xi plus 1, and this makes the rectangle this one, right? This is the area of the rectangle, If I is 1, it is x1, it is fx1, and the distance between these 2 points is this delta xi. So delta xi is this value minus this value, right? Now, if I is 1, then it is fx1 delta x1, mean this term. When I is 2, it is fx2, this is delta x2, 2, this term. So, this is area of rectangle. You can also plot these. This is the first rectangle, the blue one, whose width is delta x1. Then this red is the second rectangle, right? And whose width is delta x2, and so on. These rectangles are added in their area to get the total area under the curve fx, right? Now, what we are having, there could be many reasons that this definite integral is, for example, hard to evaluate. Mean this integral, we need value of this integral, and this value of this integral is very hard to evaluate or impossible to evaluate. Or impossible to evaluate. Impossible to evaluate. Or there could be the reason that the meaning, this integral is easy to evaluate, but result is not so much illuminating. Okay. This integral is easy to evaluate, but the result which we get is such that it cannot be used in some practical meanings, right? Or there can be any other reasons that this definite integral we don't wish to have, right? That means this sum is such that we cannot evaluate this sum, or we cannot, this sum is very hard to evaluate, or this sum is easy to evaluate, but the result is such that it doesn't suggest some practicality, right? So we wish now to change this definite integral, means this sum, into a new sum, or you can say a new definite integral. And for this purpose, let's do this new sum via a new function which we invent as k, which is a function of new variable t and the old variable x, right? So because of these reasons that this we wish to change, or we wish to get from this definite integral a new definite integral, mean a new sum, and this new sum will be obtained with the help of a new function which we invent to be k, and it depends on the new variable which you wish to invent, and it is also a function of old variable. How we do it? Let's go on the next board. Look, I plot k function alongside the fx function. This was your fx function, and you were evaluating the integral from a to b, and this is value of xi, and here is your value xi plus 1, and this is the area, this is fxi, right? Now plot a new axis, this blue axis, and this is the t-axis, mean values of t, mean new variable will be plotted here. Now this is your x-axis. The value, the point tx is, for example, this is the value for point xi, and from here you may draw a new point, this p point, and this has coordinates t and xi, right? This is starting from this point, this is O to A, big A, this is value of t, and from A to P there is the value xi, right? So in fact you have, just as you have this black figure in your xy plane, you have a new plane, the blue plane, right? This blue plane, in which point has coordinates which depend on your new variable and the old variable. And at this point, value of the function is this. Let's plot it. This is this green line. This is, for example, value of the function k at point t x I. So this is value of the function at a point txi, and this blue plane has one axis as the t-axis, which is your new variable which you wish to invent by somehow, and the other axis, mean this axis, is the old axis, right? And this value will be used, this is not a single value, as your I will change, mean point on x-axis, point in the old space, this space, xy coordinate system, this is known as physical space or Cartesian space. You may write here physical space, but this blue space is your transformed space, because you have discovered or you have invented a new axis in some way. And let's use these values to rescale the areas of the rectangles, right? Let's do this. This, the rescaled, let us rescale the areas of the rectangle. Let us rescale areas of infinitesimal rectangles in infinitesimally thin rectangles, in fact, rectangles in physical space. Okay, enough. Let's rescale. Rescale means resizing. Let's rescale areas of infinitesimally thin rectangles as, this is area of the rectangle number 1, right? This rectangle, for example, and you multiply it with value of the k function as tx1. This is value of the function for point txi, I is 1. So this was the area, and you have multiplied it with some number, and that number has been obtained from the new function k, which is a function of two variables. One is the new variable and other one is the old variable, right? And then this is ktx2 into fx2 delta x2. This is area of the second rectangle, this red rectangle, right? For example, for which this width is delta x2, this is delta x2, right? And we have multiplied it with some. When you plot, use the value x2, then this becomes a constant number in x2, right? So you have multiplied the old value of the area of rectangle with some new number, and this number is coming from the new function k. And similarly, so on k t x n, and it is to be multiplied with fxn into delta xn. So we have rescaled, mean resized the area of each thin rectangle. And how we have resized? We have resized it by multiplying the old or previous value of the area with some new value which is obtained from the new function, right? Now let's make a new sum, because we were wishing to have new sum. Now this is sum of rescaled areas. Rescaled areas. What it will be? First value is k tx1 fx1 delta x1 plus second value k tx2 fx2 delta x2 and plus so on. Last value is k txn into fxn into delta xn. Now this is sum of rescaled areas, right, under fx, the curve fx, and these are rescaled areas under fx from x equal to a to x equal to b. Now look, this sum can be written as in the form of summation limit n approaches to infinity. Not in the first place, let's write the sum. This is sum k txi into fxi into delta xi, and I is from 1 to n, and this is the same n as in the previous definition. This approaches to infinity, and these are the same delta xi's here in the new formula, so these will be approaching to 0. So apply the limit n approaches to infinity as in the previous definition, and delta xi approaches to 0. So this very sum can be written in a compact form. Now you understand that this symbol, just as this symbol, this one is this integral, and d, and this is fxi is fx, and delta xi is dx. So here you can turn this into a continuous sum, meaning the form of an integral. So R, this is sum of rescaled areas under fx from xa to x equal to b, and this is what? This is integral from x equal to a to x equal to b, right? And this k function will become a continuous function. So the variable xi is now x, mean continuous variable, fxi is fx and delta xi is dx, right? Now, be careful now. You have meanings of this new integral. This is sum of rescaled areas. These areas are areas of the rectangles. Sum of rescaled areas under fx from x equal to a to b. And this one, what this is? Integral x a to b dx. This is some real or complex number. This is some real or, for the time being it's a real function, but it could be complex function as well. And this is also a real number. So be these three real numbers or be these three complex numbers, they commute. And because of this dx I am taking in the first position, and then k dx, right? And then fx, right? And if you look carefully, then this thing, this contains dx, mean differential. So this is an operator, and when this operator is acting on fx, it is giving you something new, and that something new is sum of the rescaled areas under fx from a to b, right? But there is an integration over x. When integration over x will be done, then the variable x will be vanishing, but you will get a function of t only. So on this left side, you will have a function which will depend on t only, right? So you can look, this is your operator which is acting on fx, and it is giving you a new function, right? And the new function has its meaning here as well. The new function is again sum of the areas of the thin rectangles under fx, but these have been rescaled by the new function, right? So you can write it as, this operator is written in the with this symbol. This is I, italicized round I, and there is a curly bracket on fx, and you are getting a new function t, where I is identical, mean I is similar as x a to b dx ktx. This is the integral, definite integral operator. This is definite integral operator, which we introduced in the earlier. Right, we started from this, that you need to transform one function fx into a new function capital Ft, and you will do this by applying an operator in the form of a definite integral operator. And the question was, what is this definite integral? Here you have its answer. Here you have its answer. This is the definite integral operator which is acting on fx, and it is giving you a new function. Remember, there is an integration over x. The variable which is integrated in a definite integral, that vanishes in the final result. So there will be no x on the left hand side. So what you will be having on the left hand side is the only variable t, right? For example, look, this is sine of this is simple example, ext dx, and x is from 1 to 2. Let's take a simple example. When you integrate, then you will get e to the power xt divided by t. This is integral, and when you apply the limit of x 1 to 2, you will get, for x2 it is e to the power 2t divided by t, minus x equal to 1, mean e to the power 1t over t. Look, you have function of t only, This is some function of t only. So when you integrate a variable in in a definite integral, then the variable of integration vanishes in the final answer. The quite is the case here. This overall is an integral in your old meaning, and it is an integral over x. And when x will be integrated, then on the left hand side you will get whatever you will get, that will be a function which does not contain x. So what it will contain? It will contain only t, right? So this is ft. So again, this is an operator, it is acting on fx and it is giving you a new function. This operator is not changing only f into big F, it is also changing x into the new variable t. Look here, this is a very good example, simple example to explain the idea. This is the function at ext which is integrated with x, and here you get this is a function of t and it is different from the old function. This is exponential function e to the power xt only, but here you have some different function. At one time it is e to the power 2t over t, and then in the other place it is having e to the power t over t. So when definite integral has been done, then in general your result is a new function. That's why instead of writing little f, I have written big F on the left. And x variable has been integrated out. Look, when you say integrated out, it means the variable is vanished from the definite integral. So x will vanish, you will have a new variable. And the same thing can be written in a compact form, this ft, and this is the integral operator. It is acting on fx, and the action is represented with the help of curly bracket. Usually when you say that a is an operator and it is acting on some function to give you a new equation, for example this, right? And instead of following the old notation, the notation is also new, that I is an operator, it is acting on fx, and the action is represented by curly bracket, right? And this will give you a new function and new variable, and remember this I is this. Now there is some nomenclature that ktx, this is known as kernel of the transform. And what is the transform? ft. This new function is known as transform, and since it is obtained through an integral operator, it is known as integral transform. Remember this function, the new function which depends on the new variable, this is the transform. And since this transform is obtained with the help of an integral, it is known as integral transform. And this ktx is known as kernel of the integral transform, or a transform ft, or it has another name. It is also known as a nucleus of the transform ft, right? I hope you now understand that what is an integral transform. Integral transform, I repeat, is a new function which depends on a new variable, and this is obtained from old function. And how it is obtained? We apply this integral operator on the old function, right? Okay. This kgx has different values, has been used. For example, I give you some examples. For example, number one, ktx is equal to e to the power minus tx. This is known as kernel of the Laplace transform. Number two, ktx is equal to e to the power minus itx. This is known as kernel of the Fourier transform, and so on. There are many different transforms which are used in the literature on mathematics and physics and engineering. Remember, Fourier transform, this is kernel of the Fourier transform. And the Fourier transform is the super king or emperor of the information technology. Should there be no idea of the Fourier transform, means sure there will be no idea of integral transform. There will be nothing of the kind which we call information technology. So this is such an important topic to understand what an integral transform in general is and what are its specific cases. I have given you two. Number one, this is the first one is the Laplace transform, and this is kernel of the Laplace transform. Mean what? When you use ktx equal to e to the power minus dx here, e to the power minus dx, then this will be known as Laplace transform. And if for this ktx you use e to the power minus itx, then this ft will be known as Fourier transform. Similarly, if you invent your own function and use as a kernel, then the transform will be named after your name. Okay, thanks for watching. I hope you have some certainly new idea of integral transform. Thanks for watching. Keep watching and please like, share and subscribe, and above all press the bell icon so that my every new lecture reaches in your inbox or in your cell phone in the first place. Thanks for watching.